two types of ways that we're going to factor in chapter 5. When there are four terms like this on the left, we're going to factor by grouping. So I split it down the middle. If there happens to be more than four, you can still factor by grouping. You just need an even amount. So I look at the first two terms. I say, what is the biggest thing I can factor out? I can take a 25 because 25 and 100 are both divisible. I can also take an r squared. So that leaves me with just an r left in the first position and a -4 left there. Now, the first one is the most important because that will guide you in your second. We need, this actually should be an r. My apologies. Should be an r. So we need to find that exact thing in this. And so we have an r -4. This is a -r +4. We just need to factor out a -1. Okay? And so we have positive r and -4. So now we have two things here, the green thing and the blue thing. I mean, this is one term, and we want to factor out anything we can from these two. Well, it turns out that there's an r -4, and so we will factor out r -4, and we are left with 25 r squared and a -1. And that's factor by grouping. Now, we're not done with this question, but we are done factor by grouping. We will continue to try to factor if we can. R -4 is completely factored, but I do want to look at the 25r squared -1. This is a difference of squares. 25r squared is 5r all squared, and 1 is 1 squared. So a difference of squares, we can rewrite that as 5r -1, 5r +1. And now this is completely factored. We'll use a little bit of the same skills over here, though we're going to rely more on our quadratics. You see this is an h to the 4th and then an h squared and then a constant term. We want to think as if about this one as if it was 3h squared minus h minus 24. The reason it's called quadratic form is that it resembles a quadratic. It's not a quadratic, it resembles a quadratic. It's very similar. So how would we solve this above? How would we factor this? Well, we would multiply a times c, and then we would try to factor that in order to find a way to add together to make our b value. Well, we're going to do the same thing here. And we're going to multiply together 3 times -24. It's -72. We need to find some factors of -72 such that when you add them together, you will get a -1. 8 and 9 are factors of 72. One of them has to be negative, and it's going to be the 9. At this point, it doesn't matter, but what you're going to do is you're going to rewrite this term. -1h squared, we're going to rewrite it a little differently. Okay? We're going to have 3 still, and then h to the 4th. But then I'm going to have -9h squared. And you may say, well, wait a second. You can't just throw in a -9h squared there, and you're absolutely right. We also then are going to add an 8h squared. So in the end, even though I have separated them apart, in the end, -9h squared and a positive 8h squared would simplify to a -1h squared. It's the same thing. The blue stuff up top and the blue stuff down below are exactly the same, just rewritten. And then we've got a -24. And we factor this by the same method we factored the one on the left. We factor by grouping. What's the biggest thing I can take out of the two terms on the left? It's a 3h squared, leaving me with an h squared minus 3 over here. The biggest thing I can factor out of the two terms on the right is simply an 8, leaving me with an h squared minus 3. Again, you have to have these two terms match up in the parentheses here, otherwise it's not going to factor by grouping. and they do. So we factor that out. I have an h squared minus 3, and then a 3h squared plus 8. We'll give this a look to see if we have any difference of squares or if it's factorable in any way after this. H squared is a square, obviously, but minus 3, that 3 is not a perfect square, so we can't factor that anymore. 3h squared plus 8, anytime there's an addition there, we know it's really not going to be factorable when there's two terms like that. And that's it.